Hello guys, so we are going to begin with GP. Okay, we have completed arithmetic progression. Okay, so before starting GP I will tell you the basic things in GP. Okay, then we will do the problems. Okay, we will learn major things through problem only. Okay, so GP, geometric progression. Okay, GP, geometric progression. Okay, now like in AP, A1, A2, A3, if I take this term, okay, A4 till AN, okay, if in AP A2 minus A1 was constant, remember, while in GP if I say that these terms, okay, are in GP, what are in GP, this condition was for AP. Okay, for AP we have done so many problems on AP, are in GP. So what does it means? That A2 by A1 is constant. Okay, then only it is a GP. Okay, what do you mean? And this constant is called by R, which means common ratio. Okay, common ratio. Okay, further on we will do some basic things. Okay, like if I give you some terms like 3, 9, 27 and so on. Okay, it has A3, okay, which is called the first term, and what is common ratio R, which is nothing but 9 divided by 3, A2 by A1 or A3 by A2, okay, which is 3. Okay, like this. Okay, so we came to know about first term, common ratio. Okay, now like in AP there was last term, okay, TN, general term, what they say, we want to find the general term. Okay, I don't want to do derivation, but if you guys feel like I should do, so I'm doing it. Okay, although there is no need of derivation, you have to means learn the formula in the end. Okay, if I say AR in GP, we take terms like that, AR square, okay, like that. Okay, AR cube, okay, like that. Okay, now if I say this is T1, okay, and this is T2, okay, this is T3, okay, then at TN, okay, at TN, if you observe clearly like we did in AP, here if it is 1, R power is 0, if it is 2, R power is what, 1, so 1 less than, so when it's n, it should be a R ki power n minus 1. So we got our TN term, which is general term, which is nothing but a R ki power n minus 1. Okay, this is, okay, last term or general term, whatever you can say. Okay, general term. Okay, now this was the derivation of general term. Okay, now let me derive the summation. Okay, summation. What is summation? It is denoted by S, like we used to denote in AP. If I say that A plus AR square series, okay, like that, AR cube till how many, last term is AR n minus 1. Okay, you can take AR and AR n plus 1, doesn't matter, in the end the answer will be same only. And if I multiply this R by this S by R, what I get, R into S, it is AR square, AR cube till what, the last term will be what, AR n, and after this what term will be AR n minus 1, like that. Okay, now if I subtract what, S minus this, if I call it as 1 and I call it as 2 and I subtract, doesn't matter what you subtract 1 minus 2, I say 1 minus 2, then what we have, S minus RS. Okay, now here if you observe this term will cancel out, and this what term are left, A plus ARN. Okay, now here if I take 1 minus R as common, and here if I take 1, okay, this will be minus. Okay, this will be minus because we are subtracting this, so everywhere will be minus only. Okay, then only it will cancel out. Okay, here it will be minus, so what we have, a common, 1 minus R ki power n. Okay, like this. So what we get, S we get A into 1 minus R ki power n upon 1 minus R. Okay, we got the S, where n is number of term. Okay, n is number of term, A is first term. Okay, first term. Now what you will see that there is one more modification of this formula, which is r ki power n minus 1 upon r minus 1. This formula is just for understanding. If you get r less than 1, okay, like that, then you can use this formula. Okay, you can use this formula. Okay, while if you have r greater than 1, okay, like that, you use this formula just to just to avoid the negative sign. Okay, just to make the calculation easy. Okay, how does this formula came? Divide and multiply by minus 1 both the side. Okay, divide up means multiply means multiply by minus 1. Okay, like that. Okay, then both up and down at numerator and denominator, then what you will get? This formula. Okay, this is nothing but just the modification. Okay, just remember this formula. The first formula was Tn is equals to a r ki power n minus 1. The second formula is what? A into r ki power n minus 1 upon r minus 1. Okay, so we have derived these two formulas. Okay, now let me derive one more formula. Okay, which is sum of infinite terms. Infinite terms, okay, of GP. Okay, now if I tell 1 plus, okay, 3 plus 3 square, like that, anything, okay, 3 cube, okay, like this, it is a GP. If I tell it goes till infinity, then you will say, if I tell you to find the sum of this, you will tell its sum is infinity. Okay, so there is no means logical use of it. Okay, if I take minus infinity, okay, like that, okay, here minus till minus 3 cube, okay, minus 3 square, like that. Okay, then here will be minus 3. Okay, then what I can say here also, if I tell find the sum, you will say minus infinity. Here the sum is minus infinity, and here s is infinity, here s is minus infinity. Very simple. Okay, now when it becomes important, okay, what is the use, why we find this? Okay, if the r, okay, if the number, okay, if the r is like that, if I take 3, then 3 by 4, okay, like that, 3 by 6, 3 by, like that, means terms which are in GP only 16, like that. Okay, so after some time you see it is decreasing. Okay, now it's become interesting to find its sum. Okay, its sum will not be infinity. Okay, if the number is like that. Okay, so what is the condition of this infinite? That mod r should be less than 1. Okay, if you know this type of inequality, what does it means? It should be from 1, between minus 1 to 1. Okay, this inequality is just modified version of telling this. Okay, so if you know this, okay, then you will understand. Okay, now one more thing, how you will know when you need to use the infinite formula and sum formula, mean difference. They will specifically mention you infinite terms, okay, in question. Okay, or give you some hint. Okay, direct hint. Okay, not indirect hint. Okay, so this was the now formula. If n tends to infinity, okay, if I take the s formula, which was, okay, 1 minus r. Okay, now if n tends to infinity, r ki power n tends to 0, which gives me a upon 1 minus r. Okay, a upon 1 minus r. Now how you can differentiate it? Remember our sum formula, this was, okay, you can take any of these. Okay, doesn't matter. Okay, the main thing is that you need to, if you have okay, why we have taken this one, means where was that? Okay, yes, why we have taken this s formula? Okay, this one. Okay, because r is between 1 and minus 1, so we will use this one. Okay, when we modify it, when we place n to infinity, it just tends to 0. Okay, which gives us just the modified formula a upon 1 minus r. Okay, this is the formula of sum of infinite, okay, terms in GP. Okay, this is the formula. Okay, now we will do some questions. Okay, we will do some questions on both this. Okay, so so I have taught the things which I feel means you should know. Okay, now we will do questions. Okay, that will improve your understanding of GP. Okay, a lot of questions. Okay, so we are going to begin our first question. Okay, with this. Okay, with this one, it says if a plus bx upon a minus bx is equal to b plus cx upon b minus cx is equals to c plus dx upon c minus dx, where x not equal to 0, then show that a, b, c are in GP. How you will prove that these are in GP? Now here your basic thing will work out. Okay, whenever you get 3 or 4 terms equal, just understand that there is a chance of application of componendo and dividendo. If I apply componendo and dividendo, if I consider these two, okay, if I consider only these two, a plus bx upon a minus bx, okay, if I consider these two, okay, right, as I told, b minus cx, if I apply the componendo and dividendo, what I get, a plus bx minus a minus bx, okay, a plus bx, a minus bx, okay. Similarly, if I do here b plus cx minus b upon b plus cx, okay, plus b plus cx, b minus cx upon b minus cx, okay. Now what we get from here, we get 2bx upon 2a. Similarly, here we get 2cx upon 2b, okay. This cc will cancel out, this bb will cancel out. If I cancel these terms, what I get, b by a is equal to c by b, okay. If you simplify this, what you will get, okay. Similarly, if I compare these two, what should I get, this will be d upon c, okay, like that. Now if I take any two, okay, b square is equals to ac, which says that it is okay. One more thing, like in AP, see, problem teaches us more, means problems teaches us more than what theory can do, okay. In AP we say a b c are in AP, then what we tell, a plus c by 2, which is nothing but arithmetic mean, okay. Like in GP, that is nothing but just you will understand when we do mean, geometric mean. This is nothing but just a condition of geometric mean, geometric probability, okay, which is nothing but that if I say terms are in GP, okay, and a b c are in GP, then b square is equals to ac, okay. This is the condition, okay, just remember this, okay. Now if any 3 terms satisfy this condition, that b square is equals to ac, then it definitely means that they are in GP, okay. Now here if you multiply b square is equals to ac, means they are in GP, a b c, okay. Now similarly, c square is equals to bd, so it is also in GP. Now a b c, okay, a b c d, okay, these all are in GP, okay. You can take these two also, okay. If it is GB, you can take okay, so all are, if I place it to lambda, okay, I get a means ratio, okay, which indirectly gives me one more hint that it is in GP, okay. So what we can do, okay, we are done with this problem. We have proved that it is in GP. How? By applying component and dividendo in these two, and similarly we proved that this is also equal to this. And then if we take these two and these two, it becomes like this, which is geometric mean, okay, which proves that our point that it is A, B, C and D, comma D are in GP, okay. It was D, okay, are in GP, okay. Now let's move on to the next question, okay. The next question is as follow. The next question is as follow. The 4th, 7th and the last term of GP are, okay, they have given us T4, okay, T4 which is nothing but 10, T7 which is nothing but 80, and Tn, okay, which is 2560, okay. Now what they are telling, find the first term, okay. We want to find the first term, okay. Now T4 is what, T4 is what, AR3, AR n minus 1 na? So 4 minus 1 3, okay. Now let me do this in process, otherwise you will get surprised, which is nothing but 7 minus 1, okay. Then I can write it AR6, okay. Just remember that if you take any power T7, you have to at R power it is just less than 1, okay. It will make your calculation easy, okay. AR6, okay. Now if I divide these two, now just let me put the values. This is what, 10, I know it is AR cube 10, okay. This is what, 80 is equals to AR की power 6. If I divide these two, what I have, AR6 upon AR cube is nothing but 80 upon 10, which gives me that R cube should be equal to what, 8, which gives me R is equals to 2, okay. So I got the common ratio. Now I want to find the first term, okay. How I can find the first term? Just by substituting the values, okay. Which one is easy? This one is easy. So A into 8, I am substituting, put R is equals to 2, okay. What I have is equals to 10, so I have A is equals to 10 by 8. This is my A, which is first term, so I got one thing, okay. Now the last term is Tn A R n minus 1, okay. Now they have given me 2560 as the last term, and here I have 10 by 8 R n minus 1, Okay, now here if you see 1 0 will cancel out, which will give me 2 5 6. Okay, this is nothing but 2 की power 3 and this is nothing but 2 की power n minus 1. If I move it up, what I get? 2 की power n minus 1 minus 3. Okay, and here it is what? It is 2 की power 8. Okay, so what we get? So if I compare the terms, what I have, 8 is equals to n minus 4, which gives me n is equals to 12. Okay, so the number of terms in this, okay, in this sequence is nothing but n is equals to 12. Okay, so we got the number of terms. We means utilize all the data. This was basic, means to teach you how to use the term. Okay, AR n minus 1. Okay, this will improve your accuracy using these tricks, that if t is 7, use one number less than AR 6. Okay, these tricks will just improve your speed. Okay, so try to use them. Okay, then we moved using this trick calculation to try to make the terms same power. Okay, then it will increase your means calculation speed. Okay, so we will move on to the question number, third question. Okay, which is this question. Okay, this question, if a b c d and p, okay, are distinct real numbers such that a square plus b square plus c square into p square minus 2ab plus bc plus cd into p plus b square plus c square plus a square is less than equal to 0, then prove that a b c d, okay, are distinct real numbers. Okay, now here we can see, okay, we have done so many things in quadratic. Now we can easily see that it is forming, if I take AP, okay, minus 2AB plus B square. Okay, you can see A plus B the whole square. I can see it is forming A plus B the whole square. Now, okay, let's try to make it. This will be AP square. I'm opening it. A square P square, B square P square, C square P square. Okay, minus 2AB minus 2BC minus 2CD. This will, okay, here will be P, all will have P. Okay, further on here will be B square, C square, A square less than equal to 0. Okay, now here if I take this one, okay, and this, yes, if I take, it is nothing but AP minus B the whole square, similarly BP minus C the whole square, similarly CP minus A the whole square is nothing but equal to 0. Now distinct real terms, okay, distinct real terms can be less than 0. A square plus B square plus C square, where A, B, C are real and distinct terms. Okay, they are real and distinct. Can they be less than 0? No, not possible. So they AP minus B square the whole square plus BP minus C the whole square plus CP minus A the whole square can only be equal to 0. When will they be equal to 0? When AP minus B is equal to, they individually means A, B, C becomes 0, BP minus C becomes 0, CP minus A becomes 0, which gives me that P is nothing but B by A, P is nothing but C by B, P is nothing but A by C. Now if you can see B by A is equals to C by B is equal to A by C. Now from the previous problem you see, if I consider these two, B square is equals to AC, if I consider this C square is equals to AB, now they are in GP. Okay, it proves that they are in GP. If you get some ratio type thing and they are equal to some constant P or like that stuff, it gives you a hint that they are in GP. Okay, now let's move on to the next formula. We have proved that A, B, C, D are in GP. Okay, now okay, now let's move on. Okay, A, B, C, B, B square. Okay, okay, it should not be D, it should be A. Okay, it should not be D, there should not be any D. Okay, okay, if it is D, okay, the question is incorrect. It should be A, it should be A, it should, okay, it should not be D. Okay, then it is A. Now the question is correct. Okay, so it was more like they are forming quadratic equation, so it gives you a hint. Okay, yes, it should be A. Okay, So it gives you a hint that they will form squares, okay, which you, if move on, you get condition like this. We have seen this condition many times in quadratic equation, where 3 term square is equal, and if they have mentioned that they are distinct real terms, then the only possible condition is that they individually become 0. Okay, if they individually become 0, then that is possible. Okay, then we got that some ratio is equal to a constant number. Okay, some different ratio is equal to a constant number, which means p. Okay, which gives you a hint that it is a GP. Okay, now let's move on to question number 4. Okay, this is question number 4. Okay, now what does it tells? There exists a geometric progression, okay, containing 27, 8 and 12 as 3 of its term. If it exists, how many such progressions are possible? Okay, they are telling how many such progressions are possible if such thing exists. Okay, now how we will do this? Now the first mistake which children do, that they tell this, that this is 8, this is 12, okay, this is 27, they are in GP, so ratio should be equal to 12 by 8 should be equal to 27 by 12. Wrong, this process is wrong, because they are random. That means there some, this term can be 18th, this term can be some other, okay, 14th, okay, this term can be 4th, 5th, okay, depending on. So you cannot consider them at their like 1 2 3 term. Okay, that is wrong. Okay, that process is wrong, you cannot do that. Okay, so never do that. Don't take it A B C. Okay, because children do that. Okay, because they have means like this is the problem of theory. Okay, we teach you that A B C are in GP, then B by A, C by B should be equal, and now they consider it at A B C and then apply that condition, and they get confused why it is not equal, because they are telling here clearly that 3 of its term. Okay, they have not mentioned that they are the starting 3 terms. Okay, if it exists, okay, if it is a GP, how many such progressions are possible? Okay, we want to find how many such progressions are possible. Now if I tell that 8, 27 and 12, okay, are in GP. Okay, if they are in GP, I can take as my first term 8 as my first term. Okay, now 27. Okay, now if T, okay, 27 is some term. Okay, let me take it as Tn. Okay, some term. Okay, A into Rn minus 1. Okay, it should satisfy this condition. Okay, now what we can do, if I see the first term is 8 into r की power n minus 1. Okay, and this term is 27. Okay, 27 should be equal to 8 r की power n minus 1. Okay, if I see clearly, 27 by 8 is equals to r की power n minus 1, which is nothing but r की power n minus 1 is equal to 3 by 2 the whole cube. Okay, if I consider it as 1. Similarly, if I tell that it is some, okay, this was some n1, this is some n2. Okay, it is nothing but a r की power n minus 1, n2 minus 1. Okay, this will be n1. Okay, now okay, if I put the values, I have this 12, this is as 8, and r and n2 minus n1. Okay, now if I divide it, I get that 4 by, okay, 3 by 2. Okay, 3 by 2 is equals to r n2 minus n1. Now if you see, you can see the ratio resemblance. Okay, it is nothing but, if I take it as B, you can see it is just cube of the same number, which gives you that it is in GP. Okay, so they are in GP. So they are in GP. Okay, after seeing the ratio, okay, ratio multiplication, like it is 3 times, it is 1 time, you can clearly say that it is a GP. Now you have to tell how many such terms are possible if it is a GP. Okay, now we want to find so let's now let me take the next page. Okay, now as I have told, 3 by 2 is r n2 minus n1. Okay, and this r n1 minus 1 was r by 2 the whole cube. Okay, now if you see, it is 3 times this one, this is 3 times this. Okay, so r 3 and 1 minus 3 should be, okay, I have just taken 3 multiplied. Okay, this will be equal to r n 2 minus 1, right? Okay, now what we can do, okay, we can just equate n2 and n1, which is 3n1 minus 3 should be equal to n2 minus 1, which gives me that 3n2 will be n2 3n1, okay, will be minus, okay, plus 2, okay, times, and if I say it is some equal to some constant, okay, because it is in GP, we can say that it is equal to some constant. Then we can say that this n1 is nothing but some times 3 value, and this n2 is nothing but some lambda times minus 2 value, okay, like that. Okay, so they will give different values depending on the lambda, okay, which is equal to these three, because before some problems we have seen that they are equal to some constant number, okay, and we have assumed that constant value as lambda, okay, and then it should be lambda by 3, and this should be lambda minus 2, okay, like that. Okay, so we got the n1 and n2, okay, in terms of sub constant, okay, otherwise you can leave it here also, okay, it is fine. Okay, so we are done with this problem, okay, we have done with this problem, and we will move on to the next problem, okay, which is problem number 5. Okay, the problem number 5 is this, okay. It says there are 4n plus 1 terms in a certain sequence, of which the first 2n plus 1 terms form an AP of common difference 2, and the last 2n plus 1 terms are in GP of common ratio 1/2. Okay, if the middle term of both AP and GP are the same, then find midterm of the sequence. Okay, now they are telling you to find the midterm. Okay, now you can clearly see that 4n plus 1, if I divide, okay, it has one term common, then if I divide it in 2 and 2n, okay, one term will be common in both. Okay, you can clearly see that it is odd number of term. So if I want to make a term common in both of them, then I will divide it in 2n plus 1 and 2n plus 1. Now we will do this. Okay, now then what we can say, 2n plus 1 in AP. Okay, in AP. So then how can we find the last term? Okay, what they have told, okay, they have told, now listen what the last term, okay, and the last term 2n plus 1 terms, okay, the last term are in GP. Okay, the common ratio 1/2. If the middle term of both AP and GP are the same, okay, middle term we have to equate the middle term, okay, because the middle term is same. Now we want to find the middle term of this. Okay, what will be the middle term of this? N plus 1. N plus 1 is the middle term, right? Then if I want to find Tn plus 1, what should I do? A plus, okay, n plus 1 minus 1 into D. What I have D they have given us what? Common difference as 2. Then I will get 2n, okay, as my Tn plus 1. I got the common term of AP, means mid term of AP. Okay, I will keep it as A. Now I want to find the common term of middle term of this GP. Okay, it will also be 2n plus 1. Okay, now A into r ki power n plus 1 minus 1, which will give me A r ki power n. Okay, because this will be the middle term. Okay, I want to find n plus 1 term. Okay, now what I will do, I want to find A. If you see properly, you will come to know that the last term, means 2n plus 1 term of AP, is the first term of the GP. Okay, so if I found the 2n plus 1 term using the AP, it will be the A of GP, first term of GP. So let's find the A of this A, which will be the last term of AP, which is nothing but Tn plus 2, T2n plus 1. Okay, 2n plus 1. Okay, this will be the first term of GP and last term of AP. So A plus 2n. Okay, 1 will cancel out, giving me D, which is A plus 2 into 2, 4D, 4n. Okay, so I got it. I will keep it as B. Okay, let me keep it as B and this as C. So if I put the value, what I get, let me do here. If I put the value, I get Tn plus 1 as A plus 4n. Okay, equals to what? Equals to r power n. Okay, so we got this thing. Now what we have to do, now we know the Tn plus term, this is of GP, and the AP. Okay, these both should be equal to A plus 2n should be equal to A plus 4n into r ki power n. Okay, they both should be equal. So what we will do, we will equate them. So a plus 2n should be equal to a plus 4n. We have r value, which is 1 by 2 की power n, and if we further move on, this will be a plus 2n equals to a plus 4n upon 2 की power n. Okay, now we will multiply this on that side, which will give me a plus 2n, okay, should be equal to 2 की power n, which will be equal to a plus 4n. If I multiply it, I get a 2 की power n plus this will be 2 की power n, this is 2, so it will be 2n plus 1 into n should be equal to a plus 4n. Further on, I will move a plus 2 की power n this side and that this side, okay, because I want to find a value. Why, I will tell you. Okay, n plus 1 n minus 4n, okay, should be equal to a into a minus a 2 की power n, okay, which gives me a value, which is nothing but 2n plus 1 minus 2 की power 2 into n upon 1 minus 2 की power n is equal to a. So I got the a value. Okay, so I got the a value. Now I will tell you what was the purpose of finding a. Now I know the middle term is what, 2n plus 1. Okay, what is the middle term? 2n plus 1. Okay, this is the middle term. How I will come to know? Okay, the middle term is nothing but t a plus 4d. If I place 2n plus 1 will cancel out, d 2 into, okay, how it came like this, a plus 2n plus 1 minus 1 into 2, which is d, which gives me a plus 4n. Okay, 4n. Okay, now I have 4n. I will put a value, which will give me 2n plus 1, okay, into n into 2 की power 2n upon 1 minus 2 की power n plus 4n. Okay, let me take the next page. So if I write this here, okay, if I write this here, I get 2 की power n plus 1 into n plus 2 की power 2 into n. If I multiply this with this 4n minus 2 की power n into 4n, okay, upon what, 1 minus 2 की power n. Now this is nothing but 4n, so this and this will cancel out, which what I will left with, I will be left with 2n plus 1 into n, okay, minus 2, this can be written as 2 की power 2, which will give me 2n plus 2 into n, okay, upon 1 minus 2 की power n. Okay, now if I take 2n common, okay, if I take 2n common, okay, what should I take common? Can I form 1 minus 2 की power n? So what should I take common? Okay, okay, let's take 2 की power n common into n common. Then what we have, 2 minus 2 की power 2, okay, it is negative. Okay, let's see what we are getting, 2 की power n. Okay, now okay, 2 की power n into n, and this is 2 minus 4, okay, which this is 1 minus 2 की power n. If I move it further, I get 2 की power n into n minus 2. Okay, if I 1 minus 2 की power, if I take minus from here common, then it will become 2 की power n plus 1 into n upon 2 की power n minus 1. Okay, so we got our middle term, which was common, which is 2n plus 1. Okay, so we are done with this question. Okay, now you can see how means good level question it was. Okay, it taught us how means why we broke it in 2n plus 1. Okay, that was the main point, because 2n plus 1 will indirectly give me one term common in both. Then the last term of AP is the first term of GP. Then we know that we will, the last term, which is the common term, is 2n plus 1, which we startingly know. Okay, then what we when we equated, we got means when we apply this last term, okay, Tn, using Tn formula, a was missing. Okay, and why they have given that condition that the middle term is equal to get us a. After getting a and putting the value, we got the condition. Okay, means we got the middle term. Okay, so this was this question. Okay, this was question number 5, and it was a very good question. Okay, this type of question you can expect. Okay, it was above JEE main level. Okay, it was a very good question. Okay, now let's move on to the next question. Okay, but before that, let me tell you some things, okay, which are necessary. Okay, and in future when we solve some questions it will be useful. GP properties. Okay, now I have to teach you again and again. Okay, if I don't teach it now. Okay, what does it mean? If first property, A, B, C are in GP, okay, then it means that B square is equals to AC is nothing but geometric mean. We will study it in more detail when we move on to further lectures. Second property, if I tell A1, B1, C1 are in GP, and A2, B2, C2 are in GP, okay, then their multiplication comma division is GP only. Okay, if you don't understand, I mean this: A1 into A2 comma B1 into B2 comma C1 into C2 and so on, it will also be GP. Similarly, A1 upon A2 comma B1 upon B2 comma C1 upon C2 will always be GP. Okay, now the third property, if I take a GP, multiply, divide, single GP, okay, divide by some constant, it will still be a GP. Okay, now fourth property, if I tell A1, A2, A3, okay, are in GP, then log A1, log A2, log A3 are in AP. Okay, how this happens? See, if I say that these are in AP GP, then I can say this is A, this is AR, A2 will be what? AR, A3 will be what? AR square. Okay, AR square. Now log A, log A1 will be what? Log A, log A2 will be what? Log AR, which is nothing but log A plus log R. Okay, now log A3 is what? Log A R square, which is nothing but log A plus 2 log R. How it came? There will be 2 power here, I will move it here. Okay, now these are terms. If I call it as T1, this as T2, this as T3. Okay, let me take the next page. Okay, let me take the next page. So if I now here, if you see, if I do T2 minus T1, what I have? Log A plus log R minus log A, which gives me log R. Okay, as this is equal to T. Similar should happen when I do with T3 minus T2. What I have? Log A plus 2 log R minus log A minus log R. Okay, this is nothing but T2, which gives me again log R. So my D is same. So T2 minus T1 is constant, which is the necessary condition of AP. So they are in AP. Okay, and vice versa. If these are in GP, then this will be AP. Okay, and that is same only. Okay, you can similarly derive that. Okay, nothing much. Okay, so we are done with fourth property. Now the fifth property. Now if I say 1, 4 like that, okay, I don't mean that these terms are in GP. Okay, let me take the GP 3 square 3 cube. This is the basic GP. Okay, 3 power 4 like that. Okay, like 3 की power 5. Okay, now these are in GP. Okay, now this, okay, this property is nothing but it tells that T square is nothing but Tn minus K and Tn plus K. Okay, if I take this term, the term here n plus K, okay, third term 3 minus 1 and 3 plus 1, the product will give me this term. Similar goes for this. Okay, this term and the product of negative of this term will give me this term. Okay, so like that. Okay, so this is that property which tells you that GP between two numbers. This, if I move here 1 and here move here by 1. Okay, it will give me the same. Okay, n minus k and n plus k. Okay, n minus k and n plus k, and we will study it in more detail, okay, when we move on further. Okay, this was the formula. Now, okay, now the last thing which I will teach you is that the sixth property, which states terms assumption. Okay, terms assuming. Okay, terms assumption, which we assumption. Okay, now for three terms. Okay, three term the difference when we divide, there will be not 2r. Okay, if there is even number of terms, it should be 2r, and if there is odd number of terms, r square. Okay, if there in AP, what I told, if you divide the terms, if you take even number of terms, then if you subtract, you should get 2r 2d, and similarly if odd number terms, if you subtract 2 terms, you should get d. Okay, 1, like that. So here also, if you take odd, it should be r only, r ki power 1, and if it is even, r square. Okay, so the first is ar, a, and a by r. Three terms if you assume, you will assume it like this. If you see, if I divide this term by this, I get r only. Okay, if I divide this term by this, I get r only. Okay, so like that. Okay, this by this, this by this. Okay, doesn't matter, you get r only. Okay, so this was 3 term, and this is 4 term. Okay, 4 term. Okay, 4 term. How you will assume? Now here the difference should means when you divide, it should be r square. How it will be? If it is r cube, ar, it will be ar and ar cube. Okay, here if you divide this by this, this by this, okay, then you get r square. This by this, you get r square. This by this, you get r square. Okay, now the 5 term, you should get what? You should get 1 r ki power 1. It is only possible if it is r square. It is r, and it is a, it is ar, it is ar square. So these are the order terms, okay, which you will assume, okay, when solving a GP. Okay, so keep this in mind. Okay, so I will not I will just tell that we have studied this when we are studying GP properties, and then I will use it. Okay, so let's move on further. Okay, and take the question number 6, which is this question. Okay, which says as follow: for what value of n, a n plus 1 plus b n plus 1 upon a n plus b n is the geometric mean of a and b. Okay, now geometric mean, here in this problem they have told that it is geometric mean. This is the geometric mean. Now geometric means for 3 terms, it is nothing but the GP condition. Okay, which is what? If I tell a, b, c are in GP, then geometric mean 3 terms GP is nothing but AC. Okay, which I have told you earlier. Okay, so this is nothing new. Okay, this is nothing from geometric mean. Okay, you can do it by the things which you have learned still now. Okay, not anything extra. Okay, geometric mean is something extra. Okay, I will discuss it in detail. Okay, but this question can be done with the basic knowledge of GP. Okay, which is 3 terms condition. Okay, which is b square is equals to AC. Now they are telling that the geometric mean the b term. Okay, b term value is this. Okay, but we know if the b will be what? Under root AC. Okay, we know that b will be this, but they are telling that the b will be this. So let's equate them if it is possible. If a and b, and there is a middle term, okay, I will take it as some m. Okay, anything. Okay, which you can, but according to my condition, it should be under root AC. M square is equals to AC. If I move square here, under root AC, under root AB. So but it is telling this, so I will just equate them. A n plus 1 plus b n plus 1. Okay, a n plus b n. Okay, should be equal to what? Under root AB, which we can write at a ki power 1 by 2, b ki power 1 by 2. If I multiply this that side, what I get? A n plus 1 by 2 into b 1 by 2 plus b n plus 1 by 2 into a n by n. Okay, further on, what we can see? Okay, yes, fine. This will be 1 by 2. Okay, this will be 1 by 2. Okay, a 1 by 2. Okay, so now it should be a n plus 1 and b n plus 1. Now if I move this that side, means what we get? A n plus 1 minus a n plus 1 by 2 into b 1 by 2. This will be what? B n plus 1 by 2 a 1 by 2 minus b n plus 1. Okay, now what can, if I take n, a n plus 1 common, a1 n plus 1 by 2 common, what we have? Under root, this is 1 by 2 common, it will be under root a, this is under root b. Similarly, if here I take b n plus 1 by 2 common, what I have? Under root a minus under root b. Okay, then under root a and under root 2 will nullify, which will give me a n plus 1 by 2 is equal to b n plus 1 by 2, which is only possible if it is 0, because any constant number to power 0 is 1. Okay, it is only possible if it is equal to 0, so n plus 1 by 2 should be equal to 0, which gives me n is equals to minus 1 by 2. So here you can see there was nothing great information of geometric mean used. It was a basic application of geometric means, and there was the basic calculation which was involved here. Okay, so we are done with this question number 6, and we will discuss, means move on to question number 7. Okay, the question number 7 is as follow. The question number 7 says, if p plus qth term of a GP is a and its p minus qth term is b, okay, where a comma b is greater than 0, then find the pth term. Now here if you observe, okay, p minus q and p plus q, they have given the terms like this, means subtracting some particular number from p and adding some particular number to p. Okay, and we have discussed this thing in GP property. Okay, GP property, that this term will nothing but, means tp square will be nothing but t p minus q into t p plus q. So let's do this. It will be what? It will be, this will be a r ki power p minus q plus 1 minus 1, sorry, and this will be nothing but a r ki power p plus q minus 1. Okay, now it will become a square. Okay, this thing will become a square, and this will become p minus q minus 1 plus p plus q minus 1. Okay, further on what we get? We get a square, q will cancel out, which we get r is equals to 2p minus 1. Okay, so we got this thing. Okay, if I move this that side, okay, if I move this that side, what I get? Okay, what I get? I get a r p minus 1. Okay, I get, if I move this square, that side will be under root and this will cancel out. Okay, so tp is nothing but, if you see here, okay, tp will be what? A r p minus 1. Okay, we have proved it. Now the other way to answer this can also be that tp square is equal to tp minus q. Okay, tp plus q. Okay, then it will be what? Tp term is a and tp plus q term is b. Then if I take under root, it will be ab, under root ab. So this can also be answer. Okay, and this can also be. Okay, it is just proving this only. Okay, so we are done with question number 7, and we will move on to the next question, which says question number 4. Okay, which is question number 8, sorry. The question number 8, find 4 numbers in GP whose sum is 85 and the product is 4096. Now let's, as I have told you, when we take even number, the means the g ratio is r square. How is this possible? If I take r cube, a r cube, okay, these terms. Now here it is clearly that if I take sum whose sum is 85, if I take the product a4, product, all terms will cancel out, which will give me a4 power in the 4096. Okay, 4096. Okay, 4096, and this is nothing but 8 ki power 4. Okay, so we got a is equals to 8. Okay, so we got a is equals to 8. Now how we can further move on? Here if you see, it is telling the sum of this. Okay, we got a value as 8, so they have told that a by r cube plus a by r plus ar plus ar cube is nothing but 85. If I take a common, what I have? 1 by r cube plus 1 by r plus r. Here you can see a cube formula forming. Okay, so we will try to form a cube formula, which is nothing but 1 upon r cube plus r cube. So if I add here 2 1 upon r plus r, okay, then it will become 3 1 upon r plus r, and subtract minus 2 1 upon r plus r. So here if I make this 2 1 upon r plus r, and here I have to subtract it 2 1 upon r plus r. Okay, then it should be equal to 85. Then what we get? We get 1 upon r plus r the whole cube minus 2 1 upon r plus r, okay, should be equal to 85, which here it is a 8 which is a. So if I multiply it, what I get? 8 into 1 upon r plus r the whole cube minus 16 into 1 upon r plus r, okay. So this should be equal to 85, okay. So we got this thing, okay. Now if I take this term as t, okay, what let 1 upon r plus r equals to some p, okay. Let's take it as t, okay. If I take it, I get t cube minus 16t minus 85 should be equal to 0. Now if you observe clearly, if I take it as 2t the whole cube, I can write it as 2t the whole cube, and this as 8 into 2t minus 85 should be equal to 0. So let 2t means again substitution, it will make our question easy only. 2p, okay, 2t as p, okay, then it will be p cube minus 8p minus 85 should be equal to 0, okay. So now what we can do? What is this value? Okay, now we want to find this value. Minus 8, which term are there? Okay, so it is a cubic, okay. So we want to find it by hit and trial, okay. p1, p is equals to 1 is not where, p is equals to 2, no, 3, p is equals to 4, what we have? 64 minus 32, 30, no, not possible, 5. Okay, p is equals to 4, 64, 32 minus 85, okay. Okay, this is not p is equals to 4 is not right. P is equals to 5. P is equals to 5. 125 minus 40. What we get? Okay, we are getting 85. So p minus 5 is the root of this, and the rest thing how we will get this quadratic when we divide this, okay, by synthetic division, which is nothing but p cube minus 8p plus minus 85, and we got p minus 1 as its root, so p square, p cube minus 5p square, okay, this and this, what we get? 5p square, okay, 5 square minus 8p, what we have here? Plus 5p, what we have? 5p square minus 25p, which gives me minus plus, okay, this is nothing but if I subtract, I get 17p, okay, 17p, okay, this will cancel 17p minus 85, okay. If I divide this by 17, okay, what I get? 17p minus, okay, minus 85, okay, minus plus, okay, I get this term, which is p square plus 8p plus 17, okay. Now here we want to find its root, but check its g25 minus 4 into 17, which is less than 0, so its root are imaginary, so the only possible root is p minus 5 should be equal to 0, so p is equals to 5. Now it was what? 2 into 1 upon r plus r should be equal to 5, okay. So it should be 2 into r square, okay, r square plus 1 into 5r, which gives me 2r square, okay, 2r square plus 2 is equals to 5r. So what we have? 2r square minus 5r plus 2 should be equal to 0, okay. So what we are getting? If I solve it here, what we are getting? We are getting 2r square plus minus 4r plus r, okay, plus 2 should be equal to 0. So what we are getting? So r is equals to 2 and r is equals to 1 by 2, okay, 1 by 2. So what are the sequence possible? Now you can put the r value where a value is 8, okay. You can put the values and get the 4 terms which were here. 8 terms will be possible, okay. So this term was lengthy, okay, although the basic idea was very clear in this question. We just got the hint of forming a cubic, then again substitution, then again that this part was tricky. If you did not assume it 2t, then you might get stuck here, okay. So be careful in these questions. Okay, so let's move on further to our ninth question. Okay, the ninth question is as follow, which says three non-zero numbers a, b, c are in AP increasing a by 1 or increasing c by 2. The number are in GP. Okay, a, b, c are in AP. So I know 2b is equals to a plus c. This is the basic condition from AP. Now if GP, if I apply g a plus 1 comma b comma c, okay, a plus 1 increasing, okay, it is in GP, then what I can write, b square should be nothing but a plus 1 into c, which gives me b square is equals to ac plus c. Let me take it as 2. Now again a comma b comma c plus 2 is in GP, so here I get b square is equals to a into c plus 2, which gives me ac plus 2a. Okay, now here this is 3. Now I can equate this to what I get, this will cancel out. Okay, AC plus C should be equal to AC plus 2A, which gives me nothing but C is equals to 2A. Okay, we want to find the value of B. Okay, we want to find the value of B. Okay, so now if I put C value here, okay, if I put C value here, what I get, B is equals to 3A by 2. Okay, I got the B value. Okay, similarly if I put C value I have, okay, C value if I have, B value I have, so I can get the A value from here by putting it here. Okay, I will put here, it will be more, no, let's put it here only. So B square will be what, 9A square upon 4. Okay, should be what, A into C. A is what, A is what we want, this is 2A plus 2A. Okay, so C is 2A. Okay, so what we have, 2A square plus 2A, which is gives me 8A square plus 8A, which is nothing but 9A square. So what I have, A square is equals to 8A, A is equals to 8. So I got A is equals to 8. Okay, I got A is equals to 8. Okay, so now we want to find B. Okay, we want to find B. B how we can get, using this, B is nothing but 3 into 8 by 2, which is nothing but 12. Okay, similarly I can get C. Okay, we got the B value, that is what I wanted to find. Okay, so we got the B value, and that was the main thing in this question. Okay, so we are done with this question, and now we are going to move on to the 10th question. Okay, which is as follow. Okay, the question says, if A comma B comma C are in AP and B comma C comma D are in GP, then 1 by C comma 1 by D comma 1 by E are in AP. Prove that A comma C comma E are in GP. Okay, we want to prove this. Now what I can do, I can put the B value here, which is nothing but A plus C by 2 into D, which gives me A, okay, AD plus CD. Okay, should be 2C square. Now I want to eliminate. Okay, here there is no D, so I want to if I eliminate D from here, I have a probability of getting this. So I will do what, C square upon A plus C should be with the value of D. If I put it here, let's see what we get. 2 upon 2C square upon A plus C should be equal to 1 upon C plus 1 upon E. This 2 will cancel out, which will give me AC upon C square. Okay, this should be 1 upon C plus 1 upon E. So what we have, this will be A by C square, this will be 1 by C. Okay, this will be 1 by C, this will be 1 by E. C will cancel out, so AE is equals to C square. So if it is in GP, it should be CAE. So we have proved this. So this is our answer. Okay, the question was nothing great, just you want to focus on that here there is no D. We will eliminate the D, we will put the D value in the AP, as these two are related with each other, like these two are related with each other. So we did that and we got our answer. So now let's move on to the next question. This is the next question, question number 11, which says 3 plus 3 by 2 plus 3 by 4 till some term. Find the Sn of the following GP where n tends to infinity. Now here they have mentioned that n tends to infinity. Okay, so we want to find the R. Now as I have told, okay, as I have told that this condition occurs when it is in mod R less than 1 condition. Okay, that condition only, this so r will be less than 1. Okay, so how I will get the r value? It is r will be what, 3 by 2 by 3, which will be 1 by 2. So I got the r1 by value. So s will be what, a upon 1 minus r, which is what, 3 upon 1 minus 1 by 2, which gives me 3 into 2 upon 1, which is 6. Okay, so we got our answer, which is nothing but 6. Okay, this question was nothing but just to give you the feel of infinite. Okay, infinite sum of infinite sequence. So okay, although we will see some more questions in our next lectures, but here just the basic thing. Now the question number 12, which says, in GP of positive terms, any term is equal to the sum of the next two terms, then find the common ratio. So AR2, AR square should be equal to AR cube, means third term should be equal to fourth term and fifth term. Similarly, the first term A, okay, here if I, okay, first term should be equal to AR square plus AR cube, AR, okay. Similarly, the an minus 2 AR n minus 2 will be equal to the means two terms after that, AR n minus 1 and AR की power n. Similarly, if I did this to first term, okay, I got this. So if I divide, it means if I divide the a, means cancel the a, I get 1 is equals to r square plus r, and here you can see it is a quadratic. Which quadratic? This is nothing but a quadratic, which is r square plus r minus 1 should be equal to 0. Now you can see it is, okay, it is irrational. Okay, so let me get r value. Okay, 1 minus 1 plus minus under root 1 minus 4 into minus 1 upon 2, which I get minus 1 plus minus under root 5 upon 2. So here we got the r2 values. Now they are telling the positive terms. Okay, so we will neglect the negative r value, so we will get 1 plus under root 5 by 2. Okay, we will neglect the negative one. Okay, so this is the r value, okay, common ratio, which we wanted to find. Okay, so this was question number 12. What we did, we applied the condition, we removed the a value because it was cancelling out. Then we saw that its d is greater than 0 and it is not a perfect square. Okay, so its root will be irrational, so we got the irrational root. Now according to the condition, positive terms, which is only possible if the ratio is positive. The ratio is positive only if r is positive, so r we got positive only. We choose the r positive one. Now we are going to move on to question number 13. Okay, the question number 13 says, given f of x plus y is equals to f of x into f of y for all x comma y belongs to n, such that f of 1 is equal to 3 and summation x is equals to 1 to n f of x is equals to 120, then find the value of n. Now we want to find the value of n. Okay, now here this question doesn't seems only to of sequence series. Okay, but how we will come to know that this question is from sequence series? Now they have given us f of 1, they have told this, so we have already discussed about the summation thing, so don't get scared of that. So here f of 1 value is we got, so if this is a function, okay, for certain input it will have some output. If I want to find f2, okay, I will put x is equals to 1, y is equals to 1, what it will have, 1 into 1, which is, and I have f of 1 is what, 3, so I have f of 2, means this will be f of 2, which will be nothing but f of this 3 into 3, which is nothing but 3 square. Similarly, if I want to find 1 plus 2, if I place, what I get, f of 1 into f of 2, which is nothing but 3 into 3 square, which is nothing but 3 cube. So we are getting an idea that it is nothing but this series, 3 comma 3 square. Okay, sorry, this is like that. Now if I open this f of x, okay, x is equals to 1 to n, I have f of 1 plus f of 2 plus f of 3, like that. Okay, till what, f of n. Now f of 1 is 3, this is 3 square, this is 3 cube. Okay, and f of n is what, 3 की power n, 1 की 3 की power 1, 3 की power 2, 3 की, like that. Okay, so on the end it will be 3 की power n, and it is equal to what, 120. They have given us the value. Now we want to find the value of n. Okay, so what we will do, here we got the ratio 3. Okay, we got the ratio 3, a is what, 3. Okay, so 120 is applying some formula, which is a into r की power n minus 1 upon r minus 1. Okay, because r is greater than 1, here you can see, so we applied this version of Sn formula. So 120 should be equal to 3 into r ki r which is 3, okay, 3 ki power n minus 1 upon 3 minus 1 which will be 2, and here this will cancel out giving me 40 into 2 which is nothing but 2 ki power n, sorry, 3 ki power n minus 1, so this is 80 plus 1 should be equal to 3 ki power n, and this is 81 which is nothing but 9 into 9 which is 3 to power n, which is 3 to power 3 ki power 4 will be 3 ki power n, so n is equals to nothing but 4. Okay, so what was the main thing? We should analyze the function which was given in the problem. Like here the f of x plus f of y is equals to f of x into f of y. If I put x is equals to 1, y is equals to 1, then I get f of 1 into f of 1, okay, which is nothing but f of 2. Okay, here it will be f of 2. So like that I will analyze that it is a GP. It can anything, okay, it can be HP, it can be AP, okay, so it depends on the function given. Okay, if you have not done function, don't get scared. Okay, just don't remove the phobia of fear of submission. Okay, that is crucial. Okay, in this chapter if you do decent number of problems, this chapter removes your phobia of submissions. Okay, submissions and product. Okay, so do a large number of problems, okay, of submissions, okay, so that in further chapters you don't get scared of submissions. Okay, so here I will apply the submission condition. Okay, I will apply the sum formula, then I will compare the n, and then I will get the answer n is equals to 4. Okay, so we are done with this problem. There was nothing big in this problem, just was to analyze the function, and don't get scared with the conditions they have given. Just follow the things which are logically using the common sense, and that is all they want. Okay, in JEE Advanced also this question was of JEE Mains level. Now let's move on to this question, okay, which says suppose a comma b comma c are in AP and a square comma b square comma c square are in GP. Okay, if a is greater than, okay, c is greater than b and b is greater than a, and a plus b plus c is equals to 3/2, then the value of a is, okay, now it is in GP, so I can tell that if b is b, then it will be b minus d, and this will be b plus d. If I found the d value, okay, and b value, my job is done. Okay, I can get the AP series, I can get the GP series. Okay, this was easy one. Okay, so if I get the sum, what I have, 3b is equals to what, 3/2, the dd will cancel out which will give me 3, so I got b is equals to 1/2. Similarly now if I what I can do, here there are 3 terms. Okay, now what, b square should be equals to a square into c square. Okay, should be a square into c square using the GP condition. GP from GP, as they are in GP, square of that term are in GP. So b ki power 4 should be a square into c square. Now what I have, b ki power 4 as 1/2 ki power 4, and this is what, b minus d the whole square, and this is b plus d the whole square. So what I get, b square minus d square the whole square, and here it will be nothing but 16. If I get 4 minus d square the whole square, here it will be nothing but 1 minus 4d square upon 4 the whole square. This gets me, this is 1/16. Further on I get 1/16, 1 minus 4d square the whole square upon 16. 16 will cancel out, and here it will be plus minus 1 should be equal to 1 minus 4d square. Okay, if I move the square here, now if I take plus negative 1, minus 1 is equals to 1 minus 4d square. Okay, d will move here, minus 2 is equals to minus 4d square. I get d is equals to 1/2. Okay, d square is equals to, so I get d is equals to plus minus 1 upon √2. Okay, which one is valid? Now if d is positive, okay, if d is negative, this will be reverse. Okay, this order will not be followed. Okay, b plus d, it will be negative, so it will be less, and it will be positive. That is not, it should be less. Okay, so d is equals to 1/√2 is right. Okay, further on what we want, okay, now plus 1, if I take plus 1, this will be 1 minus 4d square, this will be minus 4d square should be equal to 0, which is not possible. D should not be less than, otherwise these 3 terms will be 0. Okay, these 3 terms will be same only, so no, not possible. Okay, now we want to find a was what, b minus d, which is nothing but 1/2 minus 1/√2. Okay, so we got the a value. Okay, so we are done with this problem. Now let's move on to the next problem. The next problem says as follow. The next problem is 15th problem, which says pth, qth and rth term of a GP are x, y and z respective. Then prove that x ki power q minus r dot y ki power r minus p dot z ki power p minus q is equals to 1. Okay, now the pth term means tp is nothing but a, r की power p minus 1, tq is nothing but a r की power q minus 1, tr is nothing but a r की power r minus 1. Sorry, I should have taken it r. Okay, this as r. Okay, this capital R. Okay, so I got the, now it is x as they have told, a r की power p minus 1. This is y, a r की power q minus 1. This is z as a r की power r minus 1. So what I get if I put the values here, a into r की power p minus 1 the whole power q minus r into a r की power q minus 1 the whole की power p minus q. Okay, sorry, this will be r minus p. Okay, r minus p. Similarly, a r की power r minus 1 की power r minus p should be equal to, we want to prove its value. Okay, now if I get a, it will be q minus r, and this will be r की power p minus 1 into q minus r. Similarly, here it will be a की power r minus p into r की power q minus 1 into r minus p, and similarly a की power r minus p into r की power r minus 1 upon r minus p. Now here if I add all the a power, this r will cancel out with this p will cancel out with this p. Okay, so I will get what, I will get, okay, p minus q. Okay, why I have put this, it should be p minus q. Okay, it should be p minus q. Okay, p minus q, and this will be p minus q. Okay, so p will cancel, this p means here this p will cancel out with this p, this q will cancel out with this q. Okay, this r will cancel out this, so there, okay, this r will cancel out with this r. Okay, so a value will become 0, a की power 0, and now dealing with r, which is pq plus, okay, minus pr, okay, minus q plus r. Here r will be what, qr minus qp minus r plus p. Here r will be what, it is p minus q. Okay, so it will be rp minus rq minus p plus q. Okay, so if I add all these value, means what, pq minus pr minus q plus r plus qr minus qp minus r plus p plus rp minus rq minus p plus q. Okay, this will cancel out with this will cancel out with this will cancel out. Okay, this will cancel out with this will cancel out with this will cancel out with this, and the last thing, this will cancel out with this. So we are getting a की power 0 and r की power 0, which will nothing but 1. So we have proved this. Okay, just put the term values and we got this. Okay, so we are done with the basic questions. Okay, in the next lecture we will start with GM, okay, geometric mean, and we will do some more questions, okay, on GP, a decent number of good questions. Okay, then you will not feel uncomfortable in GP. Okay, it will be similar to AP like you. Okay, so take care. We will see you in the next lecture.